In this video, we'll be taking a look at one very useful formula, volume equals 1/3 big B times H. Well, actually, we'll be looking at two formulas, but as you'll see, these two formulas are identical to each other. Before we get on to talking about the cones, let's take a look at this first question here involving a pyramid. So you may be familiar with pyramids. Pyramids in Egypt are probably the most uh, common or well-known pyramids in the entire world. Uh, let's see, on this particular question, why don't you try to answer it yourself without me giving you too much of a lead up. Here's the formula for it, 1/3 big B times H, and it's a multiple choice question. So pause the video and give this a try, remembering that capital B stands for the area of the base. So how did you do? Did you get all these pieces put together to make up our volume formula? Volume is 1/3 big B times H. It said it is a square, so its length and width are both 6. 6 times 6 would be the area of the base, or 36. And then all that's remaining is the height of the pyramid. In the directions, it said that the altitude was 12 inches. And the altitude is the height. So putting that all together, 36 times 12 divided by 3 comes out to be 144, which is one of the answers. So if you got 144, fantastic. And if not, remember it's just the very first example. So let's see how example 2 runs for you. And question number 2, why don't you give this a try? I know the formula might be brand new to you, but let's see if you can handle this. The base of a pyramid is a rectangle with a width of 6 centimeters and a length of 8 centimeters. Find in centimeters the height of the pyramid if the volume is 288 cubic centimeters. We'll still be using the same formula, volume equals 1/3 big B times H. But in this question, we are not looking for the volume, we're looking for the height. Give it a try and see if you can get it on your own. And then unpause the video to see if you did it. All right, so you can see my work right here, 1/3 big B times H. I know that the volume is 288, so I can park that number right there. 1/3, and big B is the area of the base. If the base is a rectangle, length times width would be the area of the base. And that leaves me with one variable left to figure out is the height, which you may have named H, or you might have called it X. So you just have to solve this equation. 1/3 of 6 is 2. 2 times 8 is 16. So very quickly the equation becomes 288 equals 16H. Dividing by 16 gives me a height of 18 for my answer. On to the next one. All right, now that you've gotten warmed up to working with volume, I'd like you to try this question here. If you can get this one right without any help, then it means that you've absorbed pretty much everything from the very first 2 examples. So give this a try and then unpause the video. All right, so in this case, the volume is big B times H again. Big B is the area of the base, and if it's a square and one side is 12, then the other sides all have to be 12. So 12 times 12 would be the area of the base times the height, which is given in the description as 42, so 216. If you had a prism that was 12 by 12 by 42, the volume of that prism would be 3 times as great as the volume of the pyramid. In other words, we can take 3 of these pyramids and melt them down and use those ingredients of melted plastic or metal or whatever it was made of. You could take the melted pyramids, 3 of those pyramids, to make one giant prism. And it's interesting that it's just very simply 1/3 the size. Speaking of 1/3 the size, we can still use the same formula as the pyramid to work with cones. The volume formula of a cone is 1/3 big B times h. Most often it's written as pi r squared h. I think that's supposed to be a helping hand to students, but I really don't like it. I like the idea that if you have a shape that is extended to a point, whether it's a pyramid or a cone or some other odd shape, you can always apply the formula 1/3 big B times h, where big B is the area of the base. And if the base is a circle, then pi r squared would be the area of the base. It's a multiple choice question. Why don't you pause the video and give this a try? How did you do? Hopefully you realized that the 8 inches was the diameter, so the radius would be 4. They're telling you that the height is 12, and it's just simply plugging those numbers in to the formula and getting pi times 64, or 201, as it turns out. So this is the exact volume. If they did not ask you to round, that would be the answer. But in this one, it would be 201 cubic inches. Moving on to seeing some more work with cones. All right, this is a next level up sort of question. Why don't you draw this picture that's being described? A water cup in the shape of a cone has a height of 4 inches and has a maximum diameter of 3 inches. What is the volume of the water in the cup to the nearest tenth of a cubic inch when the cup is filled to half its height? I would recommend drawing a picture first to try this question out. And you can unpause the video if you want to see a hint of what my picture looks like. All right, so as I've drawn on my picture here, we've got the radius of 1.5 inches at the top of the drinking cup, and that's because the diameter was 3 inches. It says that the height of the cone is 4 inches tall, but we're only filling it up half the way. Now, I'm after the volume of the water that's in the paper cup, and the water itself is in the shape of a cone. So what I'm after is the volume of the water here. And to be able to figure that out, I'm going to need to know the radius. Using the picture, see if you can figure out what the radius is, and then unpause the video when you're ready. It has been a while maybe since we've worked with similar triangles, but if that is a suggestion that helps get you unstuck, then give that a try and then unpause the video when you're ready. So since we've got two triangles that are similar to each other, the larger right triangle and the smaller right triangle, we can use similar triangles to figure out the missing measurement. And the similar triangles would tell us that the sides are in proportion. So the scale factor of 4/2 is equal to the scale factor of 1.5 over r. Cross multiplying quickly gets me the radius as being 0.75, which you might have actually guessed by looking at this. If the height is half as much as the total height, then the radius here would make sense. It would be half as big as the radius here. So there's one last thing to do is actually figure out the volume, plugging in 0.75. For the radius. Of course, I still have to do this. So 1/3 pi times times 0.75 squared times the height, which was 2 inches, would give me my volume of 1.178, or about 1.2. Oh, and it's nice that it's actually one of the answers too, so it gives me a way to feel confident with that answer. So that formula actually works for more than just cones and pyramids. It works for any shape that has um, a base whose edges actually meet at a single point. So I could turn these two-dimensional shapes into three-dimensional solids by connecting the base to a single point. So in this particular picture here, and sometimes you can even see these, sometimes these are even drawn in with little dashed lines right here. This is a pyramid with a triangular base. So if I wanted to know the volume of it, I would just take the area of the base and multiply it to whatever the height is, which of course they'd have to tell me. So volume equals 1/3 big B times H could get used for that shape. Could also work for bases that are more unusual, like a hexagonal base. So you could have a pyramid with a hexagon as its base. And that formula would also work just the same, as long as those are all meeting at a single point. Of course, you need to know the height for that pyramid. In some cases, the height is indicated outside of the picture. And the height, the shape could be slanted, but the height would always have to be perpendicular to the base. If you have some sort of unusual shaped base, like a blob, and if you picture this as being a solid that's stretched out, I guess I could just keep on adding more and more lines of sight here for you to see. I could turn that strange looking blob into a strange looking pyramid, and that volume formula, 1/3 big B times H, would still work. Of course, I need to know the height. And to figure out the base, that would be something that perhaps you're learning calculus when you deal with figuring out the area of unusually curved shapes. So here's a start of some basic questions for you to practice. Oh, and I guess that was it. That's the only thing that you have for today. And this is already looking ahead to the lesson that's coming up, or the assignment that's coming up in a couple days, which of course I'd have to show you again. That is it for today, and have a glorious day.